Yeah, welcome to the session. Hope we have enjoyed yesterday's session regarding the entropy, introduction of the entropy here, and that is the main thing for the second law of thermodynamics. So, in my definition, so you can take the losses can be taken as an entropy here, and change in entropy in my sense, because it is easy for us to understand, but general definition of the entropy is a measurement of the randomness. That's all they are saying. Randomness means how randomly the things are going out, means you can take as practically, for my understanding, I take entropy as a losses. So here in heat engines it has been clearly been indicated that if it is a Carnot reversible cycle, then dq by t is equal to 0. Means whatever the heat and been taken here, everything is been utilized properly without the losses. In the second, if it is an irreversible, then there will be some losses, because that is cyclic dq by t is less than 0. But if you go for the cyclic dq by t is greater than 0, so all the heat is converted to the work. That is not properly been, that is not at all possible. So that is the meaning of these three things. Okay, so here yesterday we have seen W reversible is a QH. Yes, in the reversible, yeah, from first law, let us second law of thermodynamics. Heat engines, from first law, W reversible is equal to QH minus QL reversible, and W irreversible is equal to H minus L reversible. So in the reversible, in the reversible case, the amount of work done, is high. The amount of work done is high. Therefore, this is what work done is high means, less losses, okay? Because most of the heat is converted into the work. So that is what you can understand. So the amount of the work done is high. Therefore, so what we can do, W reversible is greater than W irreversible, okay? Reversible is greater than W irreversible, and see also here, and thus the amount rejected, thus the amount of heat rejected, what will be here? Heat rejected will be less, correct? Amount of the heat rejected will be QL reversible is less than Q irreversible, correct? Why? Because that's what I am telling you. The heat, whatever the heat we are giving, that is being converted to the work. Maximum is converted into the work. So that compared to the irreversible, the work done by the irreversible is more, and then amount of the heat rejected will be less than the irreversible. So that is a very simple one. That's why I have given you a very understanding definition of entropy. Okay, regarding in contest with this heat engines. W reversible is greater. W reversible is greater than W irreversible because according to Carnot Principle, the efficiency of an irreversible heat engine is always less than the efficiency of a reversible one operating between the same two reservoirs. So, in the reversible cycle, integral, this is the reversible cyclic one, dq by t reversible will be what? QH by TH minus QL reversible by TL, correct? Which is equal to 0 for Carnot cycle. And thus delta Q or change of the heat is reversible is equal to 0. And in the irreversible case, now what will be in the irreversible case? The irreversible case, cyclic dq by t irreversible is equal to QH by TH minus of QL irreversible by TL will be equal to or will be less than QH by TH minus QL reversible by TL. So since QL reversible is less than QL irreversible, therefore we get cyclic dq by t irreversible is equal to QH by TH minus QL irreversible by TL is less than 0. So that is what how this changes are occurring here. So this is the main topic to understand regarding the entropy or regarding the Carnot cycle. Okay, what is cyclic dq by t is nothing but the change in the entropy, ds. Okay, change in the entropy, and if it is equal to 0 means there is no much change in the entropy. Right, like that for the reversible Carnot cycle there is no much change in the entropy system. So entropy change is 0. Okay. So in detail, let us understand for the irreversible process what are the things are there. Okay. So in detail, let us go for the entropy of the system. This is I just have given you in terms of a quick reference for you tomorrow for your exams. And this also helps for you if you are in second year or if you are in third year, if you are not completed this subject, you can also do this. So let us go for entropy change of a irreversible process. Entropy change of irreversible process. So here let us draw T versus S. T versus S. S means entropy. Two states, state 2, okay, I'll draw T here. This is A. And another one is state 1, state 2, T versus S. Okay, this is A. Fine. So here consider first a cycle in which a system goes from state 1 to state 2, goes from state 1 to state 2 and back from state 2 to state 3, state 2 to state 1 in two internally reversible process. Internally reversible process. Okay, this is the case 1. Where is A? First one. So it is going and coming back. Okay, this is the first case. In the first cycle, let us say A. Now let us go to the second cycle. Also consider a second case. You can write it as a B of a cycle in which a system goes from state 1 to 2, state 1 to state 2, state 1 to state 2, in an irreversible process and back from state 2 to state 1 and back from state 2 to state 1 in an internally reversible process. Internally reversible process. The irreversible process is represented by a broken line. So a broken line which signifies that the path 1 2 is not known. Okay, so 1 to 2 we don't know from what path to what path it is going, but 2 to 1 we know. The irreversible process is represented by a broken line which signifies that the path 1 to 2 is not known. Means it is reaching to the 2. Suppose if you want to go from Hyderabad to Delhi or your place, so you are reaching to the Delhi from Hyderabad, but what is happening is how you are going, what are the route you are following is not been known. That is what the irreversible process is represented by a broken line which signifies that the path 1 to 2 is not known. Okay, then what is the change in the entropy? The change in the entropy is equal to integral 1 to 2 from initial state to the final state dq by t of B plus S generation. S generation is entropy generation. S gen is called as entropy generation due to irreversibilities. Where S2 minus S1 is entropy change, is an entropy change of the process. It's a very, very interesting one. Entropy change of the process from state 1 to state 2. Which is a state function and does not depend on the type. We have seen in our early sessions on the type of the process taken to go from state 1 to state 2. State 1 to state 2. Because the change in the entropy, delta S, or change in enthalpy, or Gibbs energy, these are all the things are state properties. They don't bother in which route you went to Delhi. Finally, how you have reached to Delhi, that is important for that. So, S2 minus S1 is the entropy change of the process from state 1 to state 2, which is the state function and does not depend on the type of the process taken to go. See, type of the process or the path followed. You can write here, or path followed. Or path followed to go from state 1 to state 2. Path followed from state 1 to state 2. See, a new term called S-gen has been added here. Note that integral 1 to 2 delta q by t and S-gen are not properties. Are not properties as they depend, correct, as they depend on the path, correct, depend on the path, because change dq by t is the change, what is happening and how the things are happening. This is what it depends on the path. That's why S2 minus S1 is equal to integral 1 to 2 dq by t. Integral 1 to 2 means what? Integration means what? Integration means we are adding the derivatives. Adding the derivatives is integration. What is derivatives? Derivatives are small steps. Small steps means you are going from Hyderabad to Delhi, let us say. So what are the different stages you went? Finally what I say, integral from Hyderabad to Delhi. But integral Hyderabad to Delhi is 2000 kilometers. But how you are going to travel for 2000 kilometers? What are the different steps you are taking? That is the differential parts. Integral means adding the differential parts is called the integral. So, as S2 minus S1 is a final entropy. Is the final entropy what we are calculating. And dq by t is an integral from 1 to 2. How you went. Okay. And then S-gen are not properties, state properties, are depend on the path. One question may be asked. See, that's why I am writing each and everything on the board. Please note it down, because these are the very, very important points I have collected from different literatures and consolidated it and giving to you. Okay, please write down each and everything, whatever it is there on the board, and any question may be asked here. They may ask you by giving the equations S2 minus S1. Any question may ask us if they give me the chance or an opportunity to set the paper. Then I'll set according to myself. Okay, because that's what I'm telling you. There is no particular format or there is no particular textbook to give you the questions or to generate the questions. Okay. So it is up to the person how much knowledge, how much depth he is having. Based upon that, the questions will be asked. So out of my total years of experience, I am giving you all these things for you. It's very, very simple one. It's only one thing we have to learn here, whether it is a reversible, whether it is irreversible. How you are going to come? See, I am interested you to come from Hyderabad to Delhi. Okay, so what I'll anticipate, that you have to come early and you have to come healthily. You have to come with less cost. This is what we are talking here about, nothing more. So any process, if you are taking in, how much time it will take to complete and how better we can complete the process. and how much profit we are going to get it, how much losses we can getting. Suppose you are taking 3 to 4 days time to come from Hyderabad to Delhi. Generally Hyderabad to Delhi is only 24 hours. But if you are going from Hyderabad to Delhi for 3 to 4 days, you went up to some place, Nagpur, up to the bus, from Nagpur to Bhopal, Bhopal to some other place, from other place to Delhi. So what is that? And again you are coming Delhi to Hyderabad directly, let us say. So you went irreversible, you are coming reversible. Means, see, this is what a complete understanding about the system, entropy. That's what the entropy means, nothing else. Okay? So, dq by t and s generation are not properties as they depend on the path, whereas this is your this is you. Let us say this is you, and what is me? Myself is S2 minus S1, because I am bothered about that how faster you come. How you are coming, it is up to you. But finally, I see that this boy has to come in time, in 12 hours or 24 hours. Okay. So, whereas S2 minus S1 is equal to, S2 minus S1 is a property, it's a very, very important one, depends on state. Means from one state to the other state. Whereas dq by t and s generation are for the irreversible process, or s generation will not be there for the reversible process. So, okay, let us see here. I think you understood whatever I am writing here, because it is very simple. See, it is very simple that you just keep in your mind that the entropy is the losses, or the entropy, it's all depends upon for what you are talking about the entropy. Okay, so here the entropy is how much, what is the total time you are taking, that may be your entropy. Okay, in some cases what is the loss you are taking. So it is a qualitative term, it is not a quantitative, or we can quantitate it by qualitatively. So it depends on what is the situation you are, that is entropy means. Okay, so in this particular system, yeah, now let us see here. For example, consider a gas kept in a closed system. Okay, consider a gas kept in the closed system to which heat is supplied, from one side of reservoir at temperature Tr. Okay, the process is externally reversible. Yesterday we have seen what is externally reversible. The process is externally reversible when the boundary temperature Tb is equal to Tr. The boundary temperature Tb is equal to Tr. So the entropy change the entropy change of a closed system, entropy change of the closed system is given change delta S system is equal to S2 minus S1 is equal to Q by TB plus S generation. So here the entropy balance, like the energy balance what we are writing here, the entropy balance of closed system, entropy balance of closed system is described initial plus because of heat input plus generation is equal to, so the entropy balance of the system is defined or described by initial plus because of heat input plus generation is equal to final. So S1 plus Q by TB plus S generation is equal to S2. So this is the entropy balance for a closed system. Okay. The entropy balance equation can also be expressed in rate form as rate form means what is the rate? Moles per second, or with time. So ds by dt, change of entropy with time system, is equal to Q by TB plus S generation. So that is what I am telling you. This is the property, correct? This is the property and this is the path. So change. So ds by dt is equal to the path change. Means if you are arriving in 24 hours, you are coming straightly. If you are taking 2-3 days, then definitely the rate will increase or the rate will decrease, because Q by TB plus S generation, you are taking much more time to come to that. You can understand like that. What is the entropy equation? What is a rate means? The change S2 minus S1. ds means S2 minus S1. dt, change in the time, means to reach from S1 to S2, how much time you are taking. That depends upon what? The path which you are following. That is what. To reach to Delhi from Hyderabad, what is the path you are choosing? Based upon that, the rates will be there. That's all. So, whatever the process you are using, the path will decide the rate. So that is this is called as ds by dt. Okay. So you can say this as Hyderabad to Delhi. Okay, please understand like that. It will be easy for you. So you relate that with the process, whatever the process may be, because entropy is only an understanding parameter. Okay, from the process to process. Okay, So, see here, where ds by dt, system is the rate of change of entropy, of the system, and Q is the rate of heat transfer. Through the boundary at temperature Tb. So yeah, very interesting one here. For an adiabatic process, Q is equal to 0, and the change in entropy of the system is only due to the entropy generated inside the system. Okay? Because if it is an adiabatic one, then there is no heat transfer taking place. So here, for one mole of the substance, the differential entropy change of the system is given by ds of system is equal to dq by tb plus delta S generation and differential change in the total entropy of the system is given by dst of system is equal to dq by tb plus dst generation. Integrating, I told you that. What is integration? So integrating this means adding the differential systems from 1 to 2. What do we get? Total delta S total of the system is Q by TB plus ST generation. explanation. This, okay. So, reversible and irreversible. Reversible and irreversible expansion at constant temperature. Have you seen this in the Carnot cycle? Isothermal line. Isothermal line. What are isothermal lines which are there for us? Boiler and condenser. Boiler is compression, whereas condenser is the expansion. So, if a reversible and irreversible expansion at temperature, what will be the change in the entropy? For the reversible process, delta S system is equal to Q reversible by T, and delta S surroundings is equal to minus Q reversible by T, and is equal to 0. This is one observation. For irreversible process, Q irreversible by T, because irreversible has S generation. S generation here. Generation is equal to S and delta S surroundings is equal to 0. Why? Because as no interactions of the system with surroundings takes place, and S delta S universe is equal to S gen. So, a combined one I can give to you, so that it will be easy for you, as in terms of the table. That's what we have discussed now. Change of system, entropy change of system and surroundings. Entropy change of systems and surroundings due to heat transfer. Due to heat transfer due to heat transfer. Due to heat transfer. So process description. Entropy change of isothermal system, delta S of system, entropy change of surroundings, delta S surroundings combined entropy change of system and surroundings remarks. So this is the consolidated one what we have discussed so far. So process description, there are only two things. Reversible process, entropy change of isothermal system. So as we have written Q by T system, entropy change of the surroundings minus Q by TR and 0 because there is no interaction, and T system irreversible process Q by T system minus Q by TR Q into 1 by T system minus 1 by TR. So T system, just go through this and you can understand what is the entropy for this one. Okay, so we'll just have a break for 5 minutes. If you have any questions, please post it. Thank you.